Good morning all. So in today's class we will move on to the last session of the second module. So that is called hyperbolic functions. So we'll introduce what are called hyperbolic functions. Then we will look certain identities on hyperbolic functions and how to find their derivatives and integrals. So these are the main things we will be doing in this section. Okay. Now, by hyperbolic function, you mean there are certain combinations of e raised to x and e raised to minus x. So you have the exponential function e raised to x and e raised to minus x. So when you take certain combination of these two functions, you will get what is called the hyperbolic functions. The hyperbolic functions, they have so much similarity with the trigonometric functions. So you have studied different trigonometric functions, sin x, cos x, tan x, sec x, and all. You have seen different identities which connect these trigonometric functions. So similar identities you have also for the hyperbolic functions. As a function, when you look, trigonometric function and exponential functions entirely different functions are, but they have some kind of similarity when you connect them with a hyperbolic function. So the hyperbolic function has so much similarity with the trigonometric function, and this relation mainly comes when you deal with complex functions. Later on you will learn in complex analysis. Complex analysis പഠിക്കുമ്പോൾ അപ്പോൾ അവിടെ നമ്മൾ കോംപ്ലെക്സ്, if you have z to be a complex number, when you write sin z or cos z, so it's a trigonometric function that can be expressed in terms of hyperbolic function. So that is what you will learn in the advanced courses. So they can be connected in that context also. So let us define hyperbolic function in today's class. So certain combinations of e raised to x and e raised to minus x are called hyperbolic functions. Consider the function e raised to x. So you can write e raised to x in the form e raised to x plus e raised to minus x by 2 plus e raised to x minus e raised to minus x by 2. So you can see that e raised to x is equal to this sum. Now if you look at the first term, so you can see that this is an even function. So if you replace x by minus x, again you get the same value. X by minus x replace again e raised to minus x e raised to x by 2, and this is an odd function. So this is an odd function. So if you replace x by minus x, so when you take f of minus x, that will be equal to minus of fx. So e raised to x can be expressed as a sum of an even function and an odd function, and here this associated odd function is called as the hyperbolic sine of x, and the associated even function is called as the hyperbolic cosine of x. So the odd function is called hyperbolic sine of x, and the even function is called hyperbolic cosine of x. And we usually denote them as, so this is the notation for hyperbolic sine of x. We write it as sine hx. So sine hx is defined as e raised to x minus e raised to minus x by 2, and cos hx is defined as e raised to x plus e raised to minus x by 2. So when you use this notation sin hx and cos hx, this has nothing to do with your trigonometric function. Don't misunderstand it as some sin ax or cos ax where a is a constant. Okay, so this is the standard notation for a hyperbolic function. So when I write sin hx, that is a combination of exponential function. That's a trigonometric function. So sin hx is e raised to x minus e raised to minus x by 2, and cos hx is e raised to x plus e raised to minus x by 2. And this is hyperbolic sine, and this is hyperbolic cosine. Similarly, you can define hyperbolic tangent. So hyperbolic tangent will be, so we denote it as tan hx, and it is defined as sin hx by cos hx. So tan hx is defined as the function e raised to x minus e raised to minus x by e raised to x plus e raised to minus x. And then you have hyperbolic cotangent. So that is denoted by cot hx. Cot hx is cos hx by sin hx. So that is e raised to x plus e raised to minus x by e raised to x minus e raised to minus x. Similarly, you have the secant and cosecant function. So hyperbolic secant is, so that is cos hx. So that 1 by cos hx, sorry. So we denote it as sec hx. So sec hx is 1 by cos hx. So that is 2 by e raised to x plus e raised to minus x. Similarly, you have hyperbolic cosecant. So that is cosec hx. So which is 1 by sin hx. So that is 2 by e raised to x minus e raised to minus x. So these are the hyperbolic functions. So they are all combinations of your exponential functions. Now let us look at few hyperbolic identities, so which are similar to the trigonometric identities. So the first identity is, so you have, so when you take trigonometric function, you have cos square x plus sin square x, that will be equal to 1. So here you will have cos h square x minus sin h square x. So that will be equal to 1. So let us verify this. So when you take cos h square minus sin h square x, so that will be e raised to x plus e raised to minus x by 2 whole square minus e raised to x minus e raised to minus x by 2 whole square. So you will get e raised to 2x plus 2 varum plus e raised to minus 2x and minus e raised to 2x minus 2 minus 2 plus e raised to minus 2x by 4 varum. So e raised to 2x will cancel off. You will have 4 by 4, that is equal to 1. So the first hyperbolic identity is cos h square x minus sin h square x, that will be equal to 1. And again, if you divide this equation throughout by cos hx, that will give 1 minus tan h square x equal to 1 by cos h square into sec h square into. So your trigonometric identity is 1 plus tan h square x equal to tan square x equal to 1 plus tan square x equal to sec square x, and this is the corresponding hyperbolic identity. And similarly, if you are dividing by sin h square x, so that will give you cot h square x minus 1 equal to cosec h square x. So these are the main identities. So you have few more identities. Appo namakku idellam cos hx and sin hx inde value substitute cheya. So you can verify all these identities. So let us see some more identities. So you can prove all these identities by yourself. So when you take cos hx plus sin hx, that will be equal to e raised to x. Then cos hx minus sin hx, that will be equal to e raised to minus x. So the one you have seen, cos h square x minus sin h square x, that will be equal to 1, and 1 minus tan h square x is equal to sec h square x. Then cot h square x minus 1 is equal to cosec h square x. And when you take cos h of minus x, that will be equal to cos hx. So we have already seen it is an even function. And when you take sin h of minus x, sin h of minus x will be equal to minus sin hx. And the similar to the addition rule, sin a plus b sin a minus b നമ്മൾ എടുക്കുന്ന പോലെ. So when you take sin h of x plus y, that will be equal to sin hx cos hy plus cos hx sin hy. So ഇത് പ്ലസ് ഓർ മൈനസ് ആയിരിക്കും വരുന്ന. സൈൻ എക്സ് പ്ലസ് വൈ എടുക്കുമ്പോൾ ഇവിടെ പ്ലസ് വരും, അതുപോലെ മൈനസ് എടുക്കുമ്പോൾ മൈനസും വരും. Similarly, cos h x plus y, that will be equal to, okay, let us put plus or minus, so that will be equal to cos hx cos hy plus or minus sin hx sin hy. Again, cos h 2x will be equal to cos h square x plus sin h square x. നമ്മൾ മറ്റേത് ചെയ്യുമ്പോൾ cos square x minus sin square x ആയിരിക്കും വരിക. അതുപോലെ sin h 2x will be equal to 2 sin hx cos hx, that is similar. Then cos h 2x is again equal to 1 plus 2 sin h square x, and that is equal to 2 cos h square x minus 1. So these are few identities. Now let us look into why these functions are actually called as hyperbolic functions. Now when you take the equations, so consider the parametric equations. So take x equal to cos t and y equal to sin t, where you have 0 less than or equal to t less than or equal to 2 pi. So if you look at x square plus y square, that will be cos square t plus sin square t equal to 1. Okay. So this equation, so x equal to cos t and y equal to sin t satisfies the equation of the unit circle. So this is a unit circle. So x equal to cos t and x equal to sin t is actually a parametric representation of your unit circle. Now similarly, if you take x equal to cos ht and y equal to sin ht, so we have the identity cos h square t minus sin h square t equal to 1. So here you have t varying from minus infinity to infinity. Okay. So your function is well defined from cos ht and sin ht, both has domain minus infinity to infinity. It is well defined as t varies from minus infinity to infinity. So this identity holds for the hyperbolic function. So that means you will get x square minus y square equal to 1. Meaning x square minus y square equal to 1 എന്ന് പറയുന്ന curve, that is a unit hyperbola. Okay. So we have this parametric representation. So this parametric representation actually gives us a unit hyperbola. So that is the reason why these functions are called as the hyperbolic functions. So when you take